was there a pointer? Thank you. Thank you. So my talk is about NM neutron monitor data and this extensive survey we did on that. So as you all know, neutron monitors are the main method of measuring galactic cosmic ray fluxes on Earth. And of course, they are used to study flares and GLEs and Forbes decreases and other heliospheric phenomena related to the sun. And when we download data from a specific station, we usually have 4 options. We have the station homepage or web server or FTP or whatever that are operated by the teams. They can be very different. And then we have first we have the VDC, which is this old collaboration, international collaboration, and they currently host the data at Nagoya, I think. And then also Izmiran has hosted a mirror of this VDC data, but they also host their own data, and many Eastern stations can be found there. And then we also have the neutron monitor database, which is maybe the most commonly used nowadays. And we have looked through all of these to see that is the data the same in each version. And this is especially for 1 hour resolution. And these results correspond to the situation in 2020 when this survey was done. But of course, since the data can be updated or changed or corrupted or lost or anything, it will, of course, not be realistic in the future. And here is a table of all these repositories, or the main ones. And here's actually the result already that there's number of available stations in each source, and then the number of recommended or secondary source. Well, in many cases, the recommended source and the secondary source can be the same or very close, or they can be combined to make a longer data set. Just to give a quick overview of these 40 different types. So here's an example, the Oulu neutron monitor web page, where you can access Oulu and DOM C and DOM B. You make a query and you get either the plot or the values. Or then there's the Bartol Institute FTP server, where you can find their data. And one thing to note is that, for example, Bartol hasn't, they don't update the data after 2017. So after that, you have to use other sources. And I think many stations have moved to using NMDB as the sole service. And NMDB is the service created with this FP7 project in 2008. It originally hosted the European NMs, but of course later some international stations have been added. And NMDB has this interesting system of these data tables. So they have an original snapshot of the first version of the data for each station. And then when this data is updated at the max resolution possible, it's changed into this RevOri table. And there's also a separate table for 1 hour data. But since the RevOri is based on the highest resolution data, for example, 1 minute, there can be times when it's the RevOri and 1 hour are not the same, because the 1 minute data is only for specific time scale, and if you rescale that to 1 hour, it's not the same. And on the right is the Nest system. If you use a web page to access the data, how to access it. There's apparently MySQL and maybe other possible ways to access the data, but this is probably what most people use. But one point of warning for people using this, especially if you study long time series, is that at least currently NMDB doesn't really let you download like 60 years of 1 hour or even monthly data, but it will automatically decrease the resolution if the query is too long. And that process can also change the data table, which might lead to a different data than you were looking for. But maybe this will be improved in the future. VDC is, I could go on long for all the history, but it's a world data center for cosmic rays. And it has, it used to have an FTP service, but it's now an HTTPS service where you can access the data. And they have different formats of data, but they all contain the same data. But it's like back from the time when the data was on a punch card. So they had these very old formats. And VDC has the most number of stations, but they might be outdated in many cases, or not updated. And ISMIRAN is the Pushko Institute of Terrestrial Magnetism, Ionosphere and Radio Wave Propagation, and they offer that data for Russian stations and other Eastern stations, and they part of the data set is based on VDC mirror that they have, but they have also updated some data or made some corrections there. But in some cases there is no clear documentation that what has been done, but often they look quite plausible. And yeah, so when you try to get data for a specific station for a specific time, you have these 4 options. And what we noticed that many times when you access the data, you you don't get the same result for all sources. And this means that it's kind of hard to trust that where should I get for each station to pick up this data. So in order to study this, we downloaded all data from all stations and from all sources. So there's like, I think there was about 300 different, 400 different data sets. And then for each of these 4 ones, we made a comparison and all the different versions also from NMDB, and tried to find which one has the best data. For this, we used this kind of prime data criteria. So we took specific stations that they are more thoroughly explained in the publication, but long-lived stations with stable data and no notable outliers or steps and no notable drifts and so forth. And then for each station of these specific cutoff bins, there's the low one from under 1.75, and then 1.75 to 2.75, and then for higher cutoff stations, we just compare to the closest cutoff stations, because it's too large to make a kind of average. And we normalize the data to specific years. Actually, 95, 96, or 75, 76, they are quite nice because they are quite stable years. There's no notable events. And also, if you compare the levels between these separated by 20 years, they are almost the same for most stations on average. So they are quite nice years to normalize the data into. And yeah. And then when we have this prime data, we can compare the data points to the relevant prime data set. Here's a new ARC as an example. Well, from VDC, we note that VDC has Swarthmore data separately and Newark data separately. So the station was moved in the 70s place, but in other sources, they are the one data set. And then here we use 10% as a cutoff for OK data. So if it's 10% away from the prime data, then it's most probably an outlier or some kind of error or step or something. And from this we find the number of good data points. It's kind of hard to see, but you get the idea. And then, but of course, sometimes there might be some other specific occurrences in the data. So we also visually check the data, is the selection like plausible. And for example, Newark has this 4% drop in 2015 or somewhere around there, which is not inside this 10%. And from this, we have a list of all the recommendations. This is just the main recommendation source, but in the publication, you can also find the secondary sources, which is actually quite important because, for example, for many of the Bartle stations, we note that the Bartle data is the best one to use, but since they don't update after 2017, like every year we go onward and onward, it's better to switch to NMDB, which they also recommend to use. So this is already a bit outdated, but all the usable data is included. And the prime stations we used are in bold, so they are there. And while doing this work, we also had to make this huge list of all the different sources and all the specific parameters. Like, for example, different stations have different acronyms and different sources, and there might be different namings for the stations in different services. For Thailand station is Thailand somewhere, and somewhere it's this princess something name, and there's other cases too, but you can access this table too from the supplements of the publication, and there's 30 different ones which show all the available data points and the fraction of good data points that can be found. And this is a map of all the stations and the recommended source, and the size of circle is how much data there is available. And you can see that many long-lived stations have their own service, but VDC has many of these like short-lived stations saved there, and they might be something that people might not know about and don't have the data for. So we did this huge analysis, and the results are for people to use. And of course, this is in no means like the final version, but this is some kind of like a work in progress, and the station teams and NMDB and the other services, we need to work together to kind of maybe fix this situation that there is a multiple source for data and the users might not know what to use and how to get the best amount of data. And if they are studying a specific event, they might want to see where there might be data that is excluded in some other source. And here's the reference. And do you have any questions?